All right, boys and girls. Today we are talking about solving radicals. $10 set. Oof, pen is never set up correctly. But today what we're going to do is we're going to solve some radical equations. These I'm hoping are pretty straightforward and pretty easy for us. The notes are not very long. I'm hoping less than 15 minutes, but I think I can drag it out to 30 if I really try. So our goal is real quick, in and out. We're just gonna go learn some math, do like 5 examples, and then we're out of there. All right, you ready? All right, hold on to your butt cheeks. Okay, so first, what is a radical equation? A radical equation is an equation under a radical. I know, crazy, insane, but that's what we're trying to solve today. So here are going to be our steps. We're going to isolate the radical. The word isolate means get by itself. So we're going to get the radical thing by itself if we can. Then we're going to cancel the radical by raising each side to an exponent. We're going to talk about how you determine which exponent. I think all of my examples are either a 2 or a 3, but you're going to have to decide that for yourself. It changes with every problem. Okay. Once we've done that, that's going to cancel the radical, and we're going to be able to solve for x. Here's the part you're not going to like because you're lazy and there's no nice way to tell. I mean, there probably is a nice way to tell, but it's easier to just tell you to check everything than, try and teach you the exceptions and the rules and the nuance of radicals. So we're going to have to check all of our answers, which means plugging them back in, because we can get these things called extraneous solutions. The word extraneous means extra and not necessary. Actually, extra and not important, maybe. You might want to Google that before you use it in your essays for English, but it means, like, in this case, they're extra and not real. Not true. I don't want to misuse math vocabulary. So I don't think in general the word extraneous means not true, but in the math world it does. So we're gonna have to check for these extraneous solutions. There are equations that we're gonna get that are just straight up not gonna work. So we have to check for them. So let's try and follow these steps on this example. Right away, you're gonna say, Mr. Barton, how do I isolate the radical? If we have radicals on both sides, you don't. Okay. Really what you want is a radical equals a radical, and then we're going to cancel something on both sides, which will be fine. In other problems like this, you're able to get this thing by itself, so you're going to have to do that. But for this first example, we're just going to say, all right, you know what? I don't think I can get the radical by itself, so I'm going to go ahead and go to step numero dos, which is cancel the radical by raising each side to an exponent. Okay, so the way we pick the exponent is the exponent, how do you spell exponent? Exponent equals the index of the radical. The index is the little number that's on the root. Here we don't have it, so it's the invisible index of dos, of 2. So because we have a second root, the way we cancel that is with a second power. So whatever the index number is, you do that exponent. So squaring cancels the square root. Squaring cancels this square root as well. So we have 2x minus 3 equals 5x plus 1. Now we solve for x. And we're just going to use our inverse operations to do that. So we're going to try and get all of our x's in one side. So I'm going to start by moving this 2x over to be with the 5x by doing an inverse, and minus 2x. So 2x minus 2x is 0. These cancel out, and the left side goes away. Bring our negative 3 down. Bring down our equals. 5x minus 2x is 3x. Bring down our plus 1. Now we need to get rid of this plus 1, so we're going to subtract 1 on both sides. So we have negative 4 equals 3x. And now we're going to divide both sides by 3. So these cancel, and we get negative 4 over 3 equals x. This is our answer, we think, but we need to plug it back in to make sure that it works. So let's change colors so we can tell where the difference is. All right, plugging this back in to the x right there and right there to make sure that everything works out. So we have radical 2 parentheses negative 4 over 3 minus 3 equals radical 5 times negative 4 over 3 plus 1. All right. So now we're going to simplify this. So 2 times negative 4 over 3. 2 times negative 4 is negative 8 over 3 minus 3. Oops, sorry. This is not a parenthesis. That's a root. Equals root 5 times negative 4 is negative 20 over 3 plus 1. All right. Simplifying here. Negative 8 over 3 minus 3. We need to turn this into a common denominator. So this is over 3. We need to make this over 3. So negative 3 equals what number divided by 3? So what number divided by 3 is negative 3? Negative 9. So we're going to do negative 8 over 3 minus 9 over 3. Here, we need to make 1 a number over 3. That one's pretty easy. That one's going to be 3 over 3. All right. So we get negative 8 minus 9 is negative 17 over 3 equals negative 20 plus 3 is also negative 17 over 3. So it looks like they're equal and it works. However, are you allowed to take a square root of a negative? No, you're not. So this does not give us a real answer. This gets thrown away. This is what's called an extraneous solution. It doesn't work. When we plug it back in, we get something we're not allowed to do. So we throw it away and say it's extraneous. So that was our answer, but we throw it away. Now we don't have an answer. We write no real solution. And that's why we have to plug it back in. Because sometimes when we plug it back in, we get stuff that you're not allowed to do, and we have to throw it out. All right, let's go ahead and try this. So here, we need to try and isolate our radical. Well, we've got radicals on both sides, so that's not going to work. So now we need to just push on ahead and go ahead and try and get rid of the roots. So this is a square root. So what we're going to do is square both sides to get rid of it. So on the left side, the root cancels the squared, and we have 2x plus 1 equals, on this side, the 2 cancels the root, and we have just x. But this 3 isn't inside the root, so it's not really protected from the squared. So this squared hits that 3 and squares it. So 3 squared is 9. And the 3 gets squared because it's not inside being protected by the root. Now we have to solve this for x. So let's move our 2x over. So it's with our 9. These cancel. So we have 1 equals 7x. We divide by 7. And x equals 1 over 7. Now we have to plug these back in. So we're going to have 2 times 1 over 7 plus 1 equals 3 times 1 over 7 All right. So now we've got radical 2 over 7 plus 1 equals 3 times 1 over 7. Okay. Here we need to turn this into a matching denominator. So we're going to have radical 2 over 7 plus 7 over 7 equals 3 times radical 1 over 7. All right. 2 sevenths plus 7 sevenths is 9 sevenths equals 3 over radical 1 over 7. All right. If we look at this radical here, can we take a square root of 9? Yeah, definitely. It's 3. So this 9, the square root happens and it comes outside. 3 radical. Okay, we square root the 9. It's gone. So over 7. Because it's empty, we leave it as 1. Oh, look, they match. And that's our answer. If you are not one of my students, let's say you live in New York where your government cares about your education. They might make you rationalize the denominator here. So maybe let's talk about that, right? So we could say, all right, the square root of 1, that's 1. So this is really 3 times 1 over radical 7. Same thing over here. There's a rule that says you're not allowed to leave a radical 7 in the bottom. So let's talk about that, right? The way we would get rid of this radical 7 is we would multiply the top and the bottom by the radical 7. This is what's known as rationalizing the denominator. I don't know that you are necessarily going to have to do this in my class, but I'm going to show you just in case. So radical 7 times radical 7 is 7, right? This is radical 7 times radical 7. That's the same thing as radical 7 squared, and the squared cancels the radical and you get just 7. 1 times radical 7 is radical 7. So we could write this as 3 times radical 7 over 7. And we could even put the 3 up there in the numerator. So we have 3 radical 7 over 7. That's the way you're supposed to write it. But as long as you can get to here and you can see that they're not going to be imaginary, or they're not going to have a negative in the root, you're probably good for my class. You're going to have multiple choice questions anyway, so don't trip too hard about it. All right, so let me not go like that. Okay, let's go look at this one. This one, I promise, is a lot nicer. All right, this one, we don't have 2 roots, so we can isolate this. How do we get rid of a minus 5? We add 5 on both sides. All right, these cancel. Radical x equals 9. Now we have to get rid of the root. So this is a square root. So we're going to square both sides. So x equals, those cancel. So x equals 9 squared is 81. And now it's super easy to plug this back in, right? We have the square root of 81 minus 5 equals 4. The square root of 81 is 9 minus 5 equals 4. 9 minus 5 is 4. It works. So that's the answer right here. All right. 2 more, and then you're out of here. So right here, we need to isolate our root first. So we need to get rid of this plus 1. So we're going to minus 1 on both sides. These cancel. We have the cube root of x minus 2 equals 3. Now to get rid of the cube, we need to do an exponent that matches the index. So we're going to do a third power on both sides. So the third power cancels the third root, and we have x minus 2 equals 3 to the third power is 27. Now to get rid of this minus 2, to get x by itself, we add 2. These cancel, and x equals 29. Then we have to plug it back in to make sure that it works. So we have the cube root of x, we're plugging in the x. So x is 29, so where the x is, we're going to put 29 minus 2 plus 1 equals 4. 29 minus 2 is 27. So we have the cube root of 27 plus 1 equals 4. The cube root of 27, you throw this in your calculator, you throw it in Desmos, you get 3 plus 1 equals 4. 3 plus 1 is definitely 4. So it works out. So x equals 29 is a solution. All right. Last problem. We have the square root of x minus 1 equals x minus 7. The root is by itself, and it has an index of 2. So we need to square both sides so that we can solve for x. So these cancel, and we get x minus 1 equals x minus 7 squared is going to be x minus 7 times x minus 7, and we're going to have to FOIL. So x times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is another negative 7x. And negative 7 times negative 7 is positive 49. We're going to combine these like terms here in the middle to simplify. We have x minus 1 equals x squared minus 14x plus 49. All right. Now here things get a little complicated, right? We have to find x. And unfortunately, this isn't necessarily the easiest thing to do. But what we're going to do is we're going to move everything to one side, right? Just like we would trying to get the x by itself. And then we're going to try and factor. Okay. Remember, this is from our last unit. The very last thing we learned was finding zeros of polynomials. That's what we're trying to do here. So we're going to move all this stuff to one side, and then we're going to try and factor. So let's add 1 and subtract x. So these cancel, and we get 0 equals x squared minus 15x plus 50. Now we're going to factor this. So we're going to look at our factors of 50. We have 1 times 50. All right, what's another one we know? 5 and 10. Oh, okay. We can make a negative 15 with that, and we can make a 50. So to get negative 15, we're going to need x minus 5 times x minus 10 equals 0. And now we're going to set these both equal to 0, just like we did in the last lesson of last unit. And then we're going to plug those answers back in. So x minus 5 equals 0. Add the 5. So x equals 5. That's one of our answers. Here, x minus 10 equals 0. Add 10. X equals 10 is one of our other answers. And now we have to plug them back into this original equation up here, which is the square root of x minus 1 equals x minus 7. All right, so let's plug these in and see what happens. So if we plug in 5, we have the square root of 5 minus 1 equals 5 minus 7. 5 minus 1 is 4. 5 minus 7 is negative 2. The square root of 4 is 2. Does 2 equal negative 2? No, it doesn't. It's not equal. So what that means is x equals 5 is extraneous, and we throw it away. Let's try our 10 now. So we're going to plug it in here again. Let's switch to green. So we have this. That's not green. It says green. There we go. Now it's green. We have the square root of x. So 10 minus 1 equals 10 minus 7. 10 minus 7 is 3. 10 minus 1 is 9. And the square root of 9 is 3. So 3 equals 3. That's a check mark. That's true. So our only solution is x equals 10. All right. So there's your notes. Dang, a little over 20 minutes. Sorry, I couldn't do it, you guys. I just too much dilly-dallying and tomfoolery, I guess. So if you need help, please let me know. Go ahead and hop back in the WebEx, start your homework. And if you get stuck on something, ask for help. Don't just sit there and pick your nose and say, you know what, it sounds like a good time for a cigarette break. It's not a good time for a cigarette break. Ask for help. Please invest some effort into your education, and I'll see you guys next time.